let's talk about the first batch. First batch we're calling is L1. And so it is a white sand, sodium carbonate, calcium carbonate with a little bit of limestone, and 0.02 load of cobalt oxide. So that should be a fairly standard cobalt glass. So we can go ahead and come up here, those that have volunteered. And so the stamp will need to get ready with a L1. And go ahead and practice the torch. Feel free to get the feel of the counterweight on the door. Just kind of lift up and feel the general weight of it. Alright, so the zigzag pattern generally here is like this as we unload the furnace. Yep, that's right. And it's alphabetical at that point. So get where you can see the glass, or you can move up a bit, but I will need a little bit of a zone here so we can move around. And so the best place to stamp is probably to stamp back here, because I'm going to be swinging around with the hot crucibles, and as it's cooling down you can typically step up and stamp from the side. One thing to keep in mind with the torch, try to keep the torch as much as possible off the previous poured glass. And so you'll have to be a little creative with the angles, because we're going to grid it in like this, and then maybe a few others back here. So you'll have to just generally try to keep that in mind. Okay, so the first glass, cobalt glass, L1. Happen for a while. Okay, so now fire polish is got to set. Make that cool down in. Okay, that's good. Now hold on a second. Right about there would be about right. Hot, so I think that's good. So that's a pretty typical pour. Did it get you?
Oh, definitely.
Kind of feels a little toasty.
A little bit.
So the dark pigmented, the dark glass sometimes is a little heavier on the radiant heat. If that gets to be too much, you can kind of go to the end of the stamp, or you can put on a nitrile glove. Does help.
Yeah, I was thinking about that.
So those are over here. It's pretty toasty. So this is a really nice dark blue glass. So this was a full load of the cobalt 0.02. And so some of you maybe are glass collectors, or have people in your family that collect blue glass, so this will look familiar. Okay, so that was L1. Next up is M1. What's that? Right, that's just to knock down the radiant heat. I do have red thermal gloves, but maybe try that, see if that's enough. We could then move to the...
We got like a full rolling
What are those?
With those, it's hard to hold the sand.
I was thinking like work gloves. Something like that.
So I do have some welding gloves.
Oh,
yeah,
that'd be perfect.
That's perfect, yeah.
That's exactly what I was thinking of.
Thanks for
I
letting
have
me
some
choose
at home, I
those.
would have brought them.
Yeah.
I would have known about this.
I should have gotten volunteers before. Alright, this next one, M1, is the US Pigment Purified Silica, washing soda, calcium carbonate, cobalt, and sodium sulfate. It's going to be pretty similar, but with the addition of sodium sulfate. So we'll be able to compare with these two glasses the role of the sodium sulfate. Will it make a big difference in the amount of bubbles? This one looks pretty clean inside, so we'll see. So next up, sodium sulfate. Now as we're pouring, watch for subtle differences in viscosity. So how thick the liquid looks as it's being poured. A low viscosity spreads out a lot. a high viscosity spreads out not as much. You'll also hear what's called crazing. What you're hearing is little cracks forming in the glass because it shrinks at a different rate than the ceramic. So shortly you'll hear lots of that going on as we get more and more crucibles. But that little sound, every time you hear that, there's a new crack that's forming in the interior glass. So anyway, so we'll pour the next one right there. So N1, yes. This does not look like cobalt glass to me for some reason, so we'll have to see what's going on there. Okay, I think that looks good. Probably didn't have quite that deep, but that's good. It's fine. I'm just saying is that it probably didn't have to be quite that. Now, you will notice some fiberglass. Resist the urge to touch fiberglass. We have had, not under my watch, but previously there were some people that were playing with fiberglass, and it surprisingly it bends. But the problem with this is it's not like thin fiberglass that you might have for insulation. It's thick. So you bend it and you're like, hey, it bends. And then all of a sudden it snaps, goes straight, and sticks directly into your skin, kind of like a nail gun. But it can leave little chunks of glass in your finger, which is bad. So resist the urge. It's a powerful urge too. You're like, ooh, look at this. But it gets you. I've been stuck by it before as well. Okay, so this is cobalt glass, but I think the loading might be different than what's listed. So let me just verify that. This says 0.02, and the previous one says 0.02. So I think it might be down by another decimal. I think it might be 0.02 and 0.002. Because this looks typical for O2, this looks like it's about a tenth less. So I think there might be a discrepancy on the record, but I think we can figure it out. But I think that's what's going on there, because it does look a lot lighter. So, no big deal, just trying to sort things out as we go. All right, next up, we've got N1. This is, I guess, mostly Fisher purified silica with some white sand and some mason sand. So this is a mix of silica source. That mason sand has iron in it that will make the glass turn a little bit greenish in color. We then have sodium carbonate washing soda, crushed limestone as our calcium source, more iron, plus 0.4 grams of copper oxide. So this will have probably some blue plus some greenish tint from the iron. That's what we're expecting. So we'll put that one right here.
Is it N1?
This is N1. N1. All right, so going from the middle. Okay, I think it's good. And one of the things that we often see with the copper glass is the flame has some excess carbon monoxide. And I can see it already forming there. The copper, some of the copper gets reduced. in the surface layer of the glass. And so the cool thing about that is there will be a copper mirror-like appearance. And so you'll be able to see that kind of banding in on the surface of the glass. And I'll clean up these crucibles later, so we could, in theory, pick them off. I kind of chip off that glass so it's not like a bee stinger that's going to get you. But yeah, this is kind of cool. I can see, and you'll be able to see later, there's a mottled, coppery, like bands of sort of metallic-looking copper on top, and that's due to carbon monoxide in the flame before it completely combusts. It has pulled some oxygen out of the oxide, leaving this copper appearance on top of the glass. So that's kind of neat. Okay, so let's see what's next here. So next up we've got O1. That is a purified silica mason sand. Our first example of the borate. This is a half. The maximum for that ingredient is to 10. We've got 5 grams of borate. The borate melts first and helps lower the overall melt point. So be watching for a lower viscosity glass and a larger disc as a result. So far these have been kind of similar. These are a little bit smaller than the first one, but this one I'm expecting it to be a bit larger. So this also has sodium carbonate, calcium carbonate, standard pure stuff. And this one also has cobalt as the colorant. So we've got cobalt 0.02 grams, but we'll be able to compare the effect of the borate between this one and this one. They should look almost the same, except for that. So O1. All right, going from the left. Borate sometimes has a little puff of smoke too, I've seen. Gloves are working well for you?
Oh, these are perfect for it.
Yeah. You haven't lost the dexterity and you get the coverage you need, so that's good. Alright, so there's some interesting effects that happen while glass cools. And that is, they call it the temperature at which the final color strikes. They call it the striking temperature of the glass. Sometimes the color won't pop in until it seems like it's cooled down quite a bit. And the color darkens. The reason for that is the metal sits in the middle of 4 to 6 oxygen atoms. And to begin with, the oxygens are moving so quickly they haven't formed coordinated bonds with the metal. But after it cools down enough of those bonds form, the cobalt's in its final like placement, and that makes that color more permanent. Now, again, I don't know what's going on with the color. I wouldn't have guessed that to be cobalt glass. I'm sure I'm not reading this wrong. Cobalt oxide, 0.02 grams. So the mason sand would give us that green color, but I'm wondering if this is less cobalt on top of the iron color. I don't know what's going on. This is the typical 0.02 cobalt. This one says 0.02. This is cobalt dioxide. You've got manganese dioxide. That should be more purple. So there's a shroud of mystery growing on some of the colors. So maybe we can decipher this afterward. Maybe take a look at the ingredients back there, and we'll try to verify what was added to these. After we do that, I'll make a copy of our batch records so that I can post it for people to look at the batch recipes, and then you can pick these up after I scan them. But let's verify the ingredients as best we can, and then scan it, and then we will let you take these to include in your report. Okay, so next up is P1, and that one this is the new one. I'm looking forward to this all week. This is the first time we've tried sulfur carbon, which is supposed to be brownish yellow. I'm excited. So we'll see. To try that color out, we tried a really high purity batch. So this is the Fisher Purified Silica, the reagent grade sodium carbonate, and the reagent grade calcium carbonate, plus 0.16 grams of sulfur and 0.5 grams of carbon, and some sodium sulfate to knock down some bubbles. These are pretty clean so far. Few little bubbles, not a lot of bubbles. We'll put this one right here, and we're hoping for brown yellow spectrum glass there. P1. Pulling from the right. Restrike that, it's pointed out on the glass. There you go. Ironically, I see more bubbles than the one that's supposed to have the bubble reducer. So, I don't know. Maybe try angling it a little more toward me, actually. There you go. That's good. Hit that string, try to get that to go down in. Oh no, the pancake! Okay, go ahead and catastrophe. Stop a second. It's the first time this has happened. Oh! Go ahead and hit some more with the flame here. Okay, we got that. No, it was the one I wanted to see too. So go ahead and stamp that. If I can time it right, we might be able to separate it a bit.
I'll wait a little long and stamp.
It's like Siamese twins.
I don't think we'll have any problem. You have a giant crucible
Yeah,
on there.
Yeah,
It's with
I
P1.
think,
You don't need
we
this
won't
little
have a hard
stamp.
time identifying that one. These things do happen sometimes, but not usually like this. So I'm going to try to
Why would you think that?
break that off. And if I can time it right, I might be able to rock this loose.
Maybe hold the glass down with that, like,
Yeah, that's what I'm going after here. So once I get this to come apart, I hit it with that torch a bit. Try it anyway. Not quite yet.
Yes. You say it hit.
We're making this up as we go here. You want to come off of the crucible.
Somebody stuck to the end of the channel last.
Oh yeah, that'd be hilarious. It's like the guy that super glues his fingers together. And then he glues it to his eye.
Oh.
Okay.
French will make a nice little stamp too.
Yeah.
Throw it back in the furnace.
Could.
Gonna have to get a big crucible and put everything.
It'd be ugly.
Trying to get out the hammer.
Okay. Maybe we'll just
Well,
let
they
that
got two now.
Maybe we'll just let this be.
I mean, it came
You
off.
won't move that.
It came off.
Yeah, it snapped in half. That's
Just told us you don't like our group.
Anyone asked you ruined it.
Well, no, it was my fault, really, right? So, what happened there? I stopped a moment and I was talking about something.
You told them to move the angle of the torch, and
I
then
looked away.
Then you just dumped it.
yeah,
I looked away as I was moving and the bottom touched the glass. Yeah.
yeah.
Okay. So normally Dr. Ray has laser focus on this, and so I will pay closer attention to the next one. Never had one do that before. So.
Kobe, try not to do that to ours.
All right. So good news is, as long as it doesn't crack more, we'll be able to get our diameter measurement. Actually, let's go ahead and do a diameter measurement now. Sometimes when there's an exception like that on the glass, it can break further. Since this is already cracked, it's probably not going to crack further. But this one is, let's call it 73 millimeter diameter. 73. That was P1. Now, ironically, I'm not really seeing color. Yeah. So I don't know if if we burnt all that out overnight, because sulfur and carbon can get burnt out. So maybe this is too long of a batch. Supposedly this was like a fail-proof. This is how they color beer bottle type coloration, but no, I don't think so. So, okay, so moving on, Q1. This one, Fisher Purified Silica, Mason sand, majority Mason sand, 55 to 34 grams. So this will have a iron color, sodium carbonate, crushed limestone, iron oxide. So this is going to be lots of iron. And so that produces a kind of a greenish tint glass. And try to get any little shards out of the way there so it won't defect the next piece. Catch the paper on fire. It probably would too. It's hot enough, it might. Hey, why not? So, anyway, Q1 pulling from the middle, iron-rich glass. Ooh. Hit that bubble there. And this looks like it has borate in it to me. Okay,
Yeah,
so
right.
the P1, and we're going to put that into a because I think the heat's going to continue making that try to crack on us. So we'll put the pieces in here so it doesn't get thermally shocked anymore than it already has. And we'll set those up once everything cools down. Now that one has the color I kind of expected from the sulfur and carbon. So, I don't know, Dr. Ray's confused. So that one, iron can make this color, but normally
the wrong ingredient.
Are you seeing them normally
yeah, the first one was like right in line, but the rest of them I'm like up here tap dancing like, hey, this is different. So
That one.
This one, oh wait.
This is the wrong class.
If you flip it around, it might help.
No, you guys look familiar. So the Gersley borate does have this ghostly 89.92, which certainly that wouldn't be. Okay, 19.37 of the borate.
Yeah, we had to do. We were doing the math super weird, but the other side is going to have the actual like amounts of everything.
Hey. Okay, so this has 34 grams of the silica, 26 grams of mason sand, 13 grams of granusil, 19 grams of the borate. That makes more sense.
Yeah, we didn't hit tear on accident after we did the
I
first thing,
see.
so
So
we
this
were
is
adding
actually,
it up. And
this is a double loading of the borate, which is why when I poured it out, I'm like, holy cow, what's happening? So they're really spread out, which is kind of cool because now we see what a really low viscosity glass looks like. That one really spread, and that got my attention on, hey, what's going on here?
Gotta snap it back into focus.
Yeah.
It's a good thing we got rid of the other one. Though.
Right.
Touching.
So I think we're good now. So that makes more sense. We consider that it has extra borate. Borate makes it melt easier. So the Gersley borate mineral. All right, R1. Is this one yours? Okay, this one's gonna be perfect. So
I'm gonna agree with that.
this is U.S. Pigment Purified Silica 46. It's about 50-50 pure to mason sand, sodium carbonate washing soda, calcium carbonate, a 2-gram load of iron oxide, and a 0.95 sodium sulfate. So this, I think, is going to be perfect. Perfect. Yeah. This should be the opposite to this one. So this will be a iron glass, but without the borate. And so that's actually a good comparison that we'll be able to compare those to see the effect of the borate.
We're
So
gonna pretend that was planned.
it always
Yeah.
works out one way or another. So yeah, so that'll be a good control to compare those two. R1. Okay, so we will pour
So
this
strategic, we
one
didn't even know what was happening.
here.
Natural.
And then one from the middle. Yep, to the left.
Or left, sorry. Yeah.
It was really nice.
Take the pizza out of the oven.
You need to strike away from the glass. There you go. And hit that bubble on the side to make that pop. And then you just keep working it. Okay. That's probably good. So the glass today has more personality than the stuff did on Tuesday. So you guys should be proud. That bubble, the problem with the bubble is it can destabilize the surface of the glass. And so that one might crack.
So like you said, perfect.
Perfect.
So close.
But the good news is it might not. But I'm
Not a betting man.
So we will have to wait and see.
Yeah.
The color though, starting off pretty brown. We'll see if that ends up similar tint. It actually looks like it's starting to match up.
Yeah, they do look very similar.
Yeah.
I thought they were about like that.
Yeah. So
Yeah, that's Liney's for sure. Yeah. That's a Liney's color. Oh
I
yeah.
was hoping you guys would wear it again today.
in some of the questions,
Yeah.
we'll be able to
It's
see
still sitting. I haven't done washing
what's
it.
going
I'm
on
not wear
with
it
the
every
surface
Thursday
tension.
now.
The tension of the glass sometimes can cause it to be very
Next time I order
hard.
my line, I go this
But
way.
then when it shatters, it'll shatter like safety glass in the little pieces.
Remember where I put my one day.
So-
Hopefully there's no shatter.
There might not be. That bubble's down under the
Well, it's
surface,
not
which is
cool.
why it didn't pop. So it might be okay.
Lose all respect.
But it might. We'll see.
So
So
Sam Adams one.
put the next one right there. Composition S1. This one is mostly purified silica, some whites, a little bit of white sand, 10 grams to 80 grams. Sodium carbonate, washing soda, calcium carbonate, dolomite. First example of dolomite. That's a calcium magnesium. We've got 0.2 gram loading of chrome oxide. This should be green. Kind of the 7-Up bottle green, at least it usually is. And 1 gram of sodium sulfate. Chrome is the best example of a 2-color coolant. It starts off dark brown and then hits about 600 degrees and then fades to green and then goes to bright green. So watch carefully as it cools because this one will change color halfway through the cooling. And right now this metal is several hundred degrees. It hurts almost immediately to touch it. So we'll put that one right here. So, S1, yes.
Serious issues with the pork operator.
Need back up and there you go. Okay, I think that pulled in mostly. Looks good. Alright, so when we're watching the glass, just kind of, you can see on the thinner glass here, it'll have that brown to green change. It's kind of subtle. It's alright. It just needs to cool off a little more. Don't do it! I was walking across a parking lot once at a rest stop, and there was a quarter on the ground, but it was tails up. And as I went to pick it up, there was this voice, "Don't do it!" And there was this trucker way over there who was apparently watching that quarter. So when I said don't do it, it reminded me of that guy. Don't do it! Tails! Don't do it! It'll burn your skin off! I don't know, that was something. So anyway,
So did he pick it up?
I did. Which is probably why that crucible had that problem. This is like 15 years
Finally
ago.
coming back to
So,
bite you.
15 years ago, finally caught up with me today. So I don't know.
Still paying for it.
Still paying for it. That's before I worked at Stout. So arguably, Stout was, I don't know. So we'll see.
Uh-oh.
Oh, it's probably the students that like that.
Huh. Well, that looks just like the iron glass.
Yeah.
Well, we'll wait and see.
Are you sure you have the right class?
That's right, class.
They have ones on them.
I guess we'll have to wait and see what the final color looks like, but that one does not say chrome to me. You guys were reading the bottles, right, when you were measuring this stuff out? It's like the Swedish chef. And, oh, the chicken! You go in the chicken. We'll see. Hopefully, it will turn green. It could. So,
All the last three.
It says chrome oxide, so. Yeah, it does. So we're probably okay. We'll see if that gets to be darker. Oh no, wait, uranium. Yeah. Okay, T1. This is 8 grams purified Fisher silica, 10 grams silica sand, 10 grams with a line through it.
Was that half 10 grams or something?
Okay, it was going to be sandbox sand, but then they changed their mind and went with white sand.
Big mistake.
Okay. So 50 grams sodium carbonate, 25 calcium carbonate. So actually a pretty high purity batch. And on top of that, we put 0.1 gram chrome oxide and 0.1 gram manganese. So this will be green and purple. Green and purple. This is finally turning dark enough green that I'm thinking this is chrome. It's a little lighter, but it is different. So good job on that. Okay, so this will add a purple tint to the previous one, essentially. So we'll put that one right there. All right, so center, T1. Nice and slow, quick. My gloves are smoking. What's your crystals over there? They're so hot. There for a moment, my mind is thinking like they're doing the aftermath. They're like the crucible heated up the propane tank, and unknowingly, so I think we're good.
That was supposed to be green and purple?
This is a chrome manganese. So the traditional color change that should happen is it'll be brown to begin with from the chrome, and then it should lighten up to be green, and then the purple should be kind of like they're all along. So now I feel a lot better about that chrome. This is what chrome's supposed to look like. So
Perfect on the wrong one.
Yeah, that's exactly.
so this
This one seems to have a lot of bubbles for higher purity.
I don't know. There was more bubbles on this one.
So if
So
we use a different form of light, it would show a different color, like the wavelength.
some glasses are quite different in ultraviolet or infrared. We could bring in an ultraviolet, but I don't think many of these have a lot of fluorescence. There are some glasses that we've used in the past using terbium and europium that are actually pretty bright fluorescent. So this is doing the color change that's brown right now, but I think that will eventually be bright.
Yeah.
I don't know. It could actually be brown from the manganese. So we will see. I think the color will change. Let's just say. It will become less dark and probably more of a lighter brownish green, maybe. Hello.
I'm getting a lot of that. I don't know. Maybe. Might.
You guys are opening up the uncertainty because
We're special.
they're special, yeah. So one here, and then the next one will be further back. So we'll just kind of line those on across. We open up a little more real estate in the back here. Real estate.
Why don't you just set the crystals on that cart to begin with?
When they're glowing hot like that, it is a little too much for the pad. It's not like gonna like blow a hole through, but it'll smoke a little bit. So I try to let it bleed off most of the heat onto the metal first. So kind of a staged process. Heat management. I think this is lightening up a little bit. Maybe it's just your shirt that's reflecting on it. So we'll put the next one here, and that is U1. This is sandbox sand, sodium carbonate, calcium carbonate, and a heavy load of copper oxide. So this one will be even darker, I think, than here. And so watch for more of that copper mirror effect once we get rolling. But a little bit of iron from the sand, clay box sand on top of the copper oxide. So this is U1, one from the left. Next to last. Okay, I see some copper mirror going there. And then our last one, I'll have to scoot over the camera a little bit to capture the full glory. Yeah, that one definitely has the copper effect. Look at that. It's kind of a ring. Great. This one looks like it's going to have higher iron from the clay box sand than this one does. Again, it's not at this final temperature yet. Yeah, we could literally cook marshmallows once you do that. Yeah. All right. So one more. We'll put that one there.
How is this kept hot just by the hot flash being on here?
What's that?
How is this kept hot?
So the heat from the crucible bleeds into the iron, and so then it makes the whole system have to cool down because I keep adding more heat to this plate versus this one. This plate still, I'm sure, is, yeah, this is still, what, this is in between 1 and 200 degrees. I should bring my infrared on here.
So we can just cook pancakes on it.
We could.
They're overboard in
I did show this once. I put a drop of water on it, but it spattered, and a little drop of water hit on a piece of glass, and it shattered. So
That sounds kind of cool.
I don't do that anymore.
No one wants water, we want pancakes.
Yeah. With an extra little crunch because of a little piece of glass in it. It's like, oh, Dr. Ray's pancakes. So this last one is another example of borate. We've got 9 grams of 9.8 of borate, 80 grams purified silica. So we would predict, just a prediction, that it would be somewhere in between this one and this one in size, because this was a double load of borate, and so it'll hopefully be a progression between those. So we'll put that here. After we get all the batch records maybe corrected or finalized or whatever, you can look back through the data on the video and the data on your millimeter diameters and try to, make sense of the trends that we find, which I think they are here. So right here. So then this has a manganese dioxide, sodium carbonate plus washing soda, which is just really still pure sodium carbonate. It's just sold as a laundry booster. Crushed limestone, a little bit of iron from that, but this is 0.2 gram manganese dioxide. So this one will be more traditional purple. So it should be lighter than this one because the chrome tilted that one towards brown. But there'll be a slight yellow from the iron plus the manganese, but this one I'm expecting to be purple and a little bigger than this one, or a little smaller than this one, bigger than this one. Maybe. So, V1, last but not least. I'm trying to predict them so you have faith in science, but it's been a bit of a challenge this time.
You're not improving our faith in science.
Yeah, so far. Okay, hit that bubble, try to get that to go away. And that's probably going to persist, so maybe switch to the...
There. Got it.
There you go. So you can switch some heat to the edge now too to sort of finish that up. Get it to fill in a little bit. Okay, I think that looks good. You can tell from my fiberglass that we are going to get purple color. Light purple. Right. So, overall, no one's bleeding, so it's a success.
Yet.
Yet. Yes. So what's going to happen next is these have to cool a bit before we can take a look at them. We're going to watch those two videos. That takes about 15-20 minutes. Well then, while they're still hot, we can take some of the linear measurements. Once they cool down a little more, we'll move them over here to the light table. So we'll take the last sections off, but you can look at their coloration too. And we will also look for internal stress. You might not know this, but with cross polarizers you can see internal stress. You ever heard this? Polarized light is an interesting thing. You see how that goes dark when I tilt it? So when you cross the polarizers, you can model it classically like the wave of the light. The electric vector is like shaking a string up and down. It's tied to a tree. A sine wave, yes. And it fits through slots in a picket fence vertically, but if I were to shake back and forth, they would be blocked and couldn't propagate through the fence. This is a classical mechanical model to describe what's going on, but it doesn't necessarily perfectly hold true. But if you cross the polarizers and then put a piece of glass in between, you can see any shift in polarization caused by the glass. And I don't know if you can see it, but I can see it. You see this rainbow striations of color. The tightness of that pattern is directly proportional to how much internal stress there is in the glass. If you anneal the glass, it all goes to kind of like a gray color without these bands of color. But we'll be able to see lots of stress since this is surface quenched glass. I've also got some pieces of injection molded polystyrene, different shapes, forks and spoons and such, and little dishes. The cool thing about this is these also show preferred orientation. And you can see where it was injection molded. You can see the path that the polymer took if you know what you're looking for. So for both glass and plastic, simple cross polarizers are actually